is now starting. All attendees are in listen-only mode.
Welcome to today's webinar entitled, There's More to Roof Replacement Than Roofing. My name is Billy Zidek, Manager Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage under the Continuous Learning tab later today. Professional continuing education certificates are being offered for today's program. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. At this time, it's my pleasure to turn this over to our speaker for today, Chris Musafidi. Chris, take it away.
Thank you, Billy. Welcome, everybody. I know it's after lunch. You're all probably ready for a nap. I'll try to keep you awake as much as possible. The purpose of this presentation is to remind everybody that there's really more to just replacing the roof than replacing the roof. There are things that you need to take into consideration so that we don't have some major catastrophes, such as the, give me a second. Isn't this working? Here we go. Sorry about that. Such as major catastrophes as roof blow-offs, significant ponding water that can create a structural issue, or actual collapses, which could result in some significant structural and potential life safety issues. Looks like the roof is pretty much delimited completely. It has pulled apart a lot of the brick masonry of the parapet walls. It's all very costly to replace. A lot of water infiltration into the system. The lower left-hand photo, ponding water. This could be a result of improper capacity to handle the amount of water that's up there, obstructions in the roof system that could be preventing water from getting to the drains. And the roof on the right, which was an original green roof, not having enough snow load capacity and or water management during heavy snows can result in a significant amount of weight, which could buckle some of the structural components. So the intent of this presentation is to go over the roofing, look at code requirements and other industry standards that might be associated with your roof replacement, look at rising walls because there are often conditions with items directly above the roof system that could be contributing to water infiltration that you want to address. Take a look at your rooftop equipment, potential modifications you can do associated with them, all in anticipation for future renovations down the road, because there's a good chance the service life of your building will require that you might need multiple roofs on it in the future. So, requirements. These are just a minimum as to what Gale looks at. They are the highlights. Gale is mostly focused in, or I'm focused in the Massachusetts office, so most of this presentation is going to be based on what we see up here in Massachusetts. We do go by the International Existing Building Code, and there are some code commentaries associated with them, as well as some amendments. But items that we want to look at are the long-term thermal resistance, drainage capacity to make sure that your roof can handle what type of water you might have with respect to precipitation events, what the wind uplift capacity would be so that we don't have a blow-off, gravity load, which also includes some snow load analysis, maintaining an egress path, because in Massachusetts we have a lot of older buildings that might be interconnected that require access onto a roof in order to provide a second means of egress, as well as some solar ready requirements. Again, there are other things that we'd probably want to take a look at. The code is basically the minimum requirements that you need, but there are industry standards such as the National Roofing Contractor Association, SMACNA, Copper and Common Sense. You need to look at OSHA requirements with respect to fall protection, other items that could impact your roof system. So just briefly, thermal resistance. This is a map that identifies the climatic zones as to where you might need to have certain types of insulation, which is specified by the code. It specifically identifies your climate area and what the minimum requirements for insulation thickness would be. This is to reduce the amount of thermal transmission you have through a roof system or assembly. It can also be used for walls. There are other tables associated with it. But as you can see in the highlighted smaller table here, if you needed to provide a roof insulation system directly above the roof deck, you will probably need an R30 continuous insulation above it. And anything associated with below deck or metal framing would have a combination of either a continuous insulation above with complete additional insulation below the deck, or you might have to have strictly all of your insulation underneath, such as an attic roof system where you might need an R38. There are other associated items with thermal resistance where you might need to take into account solar reflectivity, which could also be an important factor when you're trying to consider what kind of insulation you have. But most of the thermal resistance is based on a long-term thermal resistance factor, which is put together by PIMA, or the Polyiso Institute, as well as NERCA requirements. Other things that you need to consider is an air barrier. New construction does require that you have a continuous air barrier around the entire envelope. That would typically be provided on the warm side of construction, so it also acts as a vapor retarder. Air barriers, however, are not always required. There's always an exception, specifically if you're doing a cold building or cold storage building in the New England or upper climates where it's really cold. The air barrier may not be required on the interior unless you do a thermal calculation to identify it, because really the exterior of the building is going to be warmer than your interior of the building, so your roof membrane or exterior building envelope components can act as that air barrier or vapor retarder at that point in time. Roof drainage, again, we talked about it briefly. You want to make sure that you have the capacity of your roof system to handle the amount of water that you will be getting on your roof during a 100-year storm. We don't want to have ponding water like we have in the upper right-hand corner, because that can not only impact the structural capacity of the roof system. The more water you get on there, the more deflection you'll have in the deck. The more deflection you have in the deck, the more water you'll have on there. It's a vicious cycle. Also, if you've got some roof systems that are susceptible to ponding water on there, you could potentially void your warranty. So making sure you have roof drains that have the appropriate leader line dimensions to handle that capacity, providing overflow scuppers if need be in order to provide a secondary means of water evacuating the roof system, or even integral overflow drains, which would be next to the primary drains. They would require that you have a totally separate leader line system, but it is required as part of the new code in order to make sure you have enough capacity in case the primary drains are obstructed. Another important factor to keep in mind is making sure that you have the appropriate slope to drain, because if you don't have a significant slope, you're going to potentially have additional ponding water. Things to keep in mind is if you've got less than a 1/4 inch per foot slope, the building code will also require that you do a structural analysis to make sure that you can handle the amount of rain or snow that you will have on that roof system. Vent pipes, In the state of Massachusetts, it's required that we have a 2-inch minimum wide or inner diameter vent pipe. We also want to have it 24 inches or 18 inches above the finished roof surface. The reason for that is so that you don't have a lot of snow accumulation, which can obstruct them. One of the reasons why I bring this up is that it's often missed in the older buildings that are out there where they used to have 1-inch piping that provided the vent piping. So it's something that we'd want to take a look at in order to make sure that you can provide the appropriate ventilation for exhaust stacks. Transitions, roof-to-roof transitions are typically handled by an expansion joint of some sort, which can be incorporated in, and you could probably use some of the manufacturer standard details. but more importantly are what's going on outside or around your system. Because if you have issues with water getting into your building, such as we had in some of these examples, and a roofing contractor or general maintenance guy goes out to just address where the water might be coming in from, you might be making it worse. Specifically the upper left-hand corner where we've got a piece of EPDM rubber that was secured up on the parapet wall onto that brick masonry. Well, they were having a leak there. And by doing this, they actually made the leak worse because water is getting in through the brick masonry, finding its way down below. Now it's trapped even worse, and it's getting into the system. The photograph in the right-hand corner is an addition that was put on, and the contractor basically took the EPDM flashings and went right up to the window glazing components. Now, windows are designed to leak. They're only good for a certain amount of wind pressure, and after that wind pressure is exceeded, the glazing gaskets do deform slightly. So if you get a good wind-driven rain and you've got your EPDM flashings directly up to your glazing units, you're going to have water getting into your roof system and into your window system as well. So without having that appropriate transition, you're making your building worse. And then the lower photo, you can kind of see those birds there that are making some condominiums. Basically, if you don't have your sheet metal coming down and counter flashing things, you have the potential for pest infiltration to get in there. This is at a main entrance of the building, and you can imagine how people feel when they're getting dive bombed by birds or there's bird guano around the area. So keeping those things in mind help you identify the transitions and address items. We also need to consider wind uplift capacity. Wind uplift capacity is basically what are we doing to reduce the potential for wind forces acting on our roof or potentially interior forces that could be pushing up on it that could result in a failure. Typically, you would want to go with ASCE 7 or the International Existing Building Code in order to identify what the minimum wind pressures are. ASCE 7-10 is what most codes are using. However, a lot of codes have recently been adapted into the ASCE 7-16 version, as well as Factory Mutual Global, who's one of the leading industry insurance providers, which most of the roofing design standards are adhered to. But what we want to do is identify where the field of the roof is, what the perimeter and corner attachments might be, because you will have different enhancements in order to resist the wind uplift requirements. The photo on the left is a typical bubble machine, which is used to do basically a destructive test on the roof surface. You would literally hook this up to a glorified shop vacuum and suck on it in order to see if your roof is actually adhered in place to a certain pressure. This is typically required as part of a Factory Mutual Global insured building, unless you were to go through and do a visual observation of the entire roof surface. So if anybody wants additional information on that, that is in the Factory Mutual Global data sheet, FM1-52. Gravity load analysis, which also leads into a snow load analysis. Basically, the code requires that if you exceed the original design intent of an existing building by more than 5%, you are required to perform an additional structural analysis to make sure that the forces on that structure are not being exceeded. So in doing load analysis, you want to compare what did you have for a roof system? And this usually can be provided by, if it's the original roof, or if you have original as-built drawings to identify what those loads are. You compare that with what the new roof system is. Again, roof systems will require that you have a larger amount of insulation on there. You might need to meet UL factors with respect to providing a baseboard that will provide you with the fire resistance. So you need to take into account that there may be additional loads on your existing roof system that might need to be reviewed and addressed. Maintaining egress, again, in Massachusetts, we have a lot of older buildings. Some of those older buildings egress onto other buildings. So it's not something that you would typically have in a commercial industry, but it's something that you want to take into consideration in case for some reason you have a shop that would require a second means of egress and you need to get out of the building relatively quickly. The photo on the right, again, an old building, there's a fire escape that goes down to a lower roof. Then there are two paths. You go back into the building. You want to make sure that those are clear. The left-hand photo is an image from a shop where people needed to get out quickly if there was an emergency. So things that you need to consider. Do you have a solid walking surface in order to provide that? Do you have something in place, as in these rails, in order to get them to the door that they need to go through so that they're not wandering on the roof? Do you have some form of water management with respect to that egress pathway? Specifically, the photo on the left, again, you can see that there's some buckled insulation to the right of the walkway, and there's some dirt staining, which is some evidence of ponding water. You can also see that there is some algae or moss growth in the background up against that wall system. Those are all potential concerns when you're looking at your roof system that can result in some damage, result in some water infiltration, result in some slip hazards. So those are things that we want to take into consideration when looking at your egress path. Rooftop solar. This is getting very popular these days. The codes do require in Massachusetts that if you have new construction, it has to be solar ready. So making sure that your building can handle, especially if it's an existing building, handle those additional loads. Are you able to get a configuration in place that will not obstruct drainage? Do you have to worry about egress paths on here as well? Specifically, do you need to maintain these units? Do you need to provide fall protection around the perimeter of your roof so that you can easily get around it? Have you done your structural analysis to make sure that there's no deflection in your roof deck, which again could result in more ponding? Have you considered, before you put your solar equipment on here, how old your roof system is and what your potential duration or lease requirements are for your solar panels? Because if you've got a roof system that's older than 5 years, there's a good chance that you're going to have to replace that roof in the future. And if you look at your solar contracts, there's a good chance that you may be responsible for the disconnection, de-energization, re-energization, and installation of these units, which you might not take into account when you're first doing your consideration for your roof replacements. Rising walls. Again, there's not just roofing to roofing. Rising walls can be a major issue. You can put on a perfect roof system, but if you don't address some of the rising wall concerns, you could have water infiltration into your system. Specifically, brick masonry is naturally absorbent. A good wind-driven rain can allow a significant amount of water to accumulate in it, which could get down into your flashings. If you have counter flashings or your roof membrane is secured directly to the brick masonry, you're now going to allow water to get behind there. And you can go through and you could take a look at your roof membrane. It may look perfect. You may not know why. This is one of the items that could be a concern. You might need to do new through-wall flashings. You might need to do masonry repairs. You might need to do some coating, some wall claddings. The photo on the right shows metal cladding and multiple ceiling patches. If you don't have the appropriate water management behind the wall panels, because wall panels are not considered watertight, you could allow water to get in. If you don't have the appropriate transition between two sections or an expansion joint, you can allow water to get in. Just a couple close-ups of those same photos. Again, you can see there is some deteriorated mortar in that wall, which was actually allowing water infiltration in. And the right-hand side where that expansion joint matches, just below or to the right of that cable and or to the left of that green panel section, that wasn't tied in. It's not really intended to be, and it allowed a fair amount of water in at those expansion joint locations. Again, without the appropriate water management for the above roofline conditions, you can let water in. Excuse me. Some things for consideration when you're looking at rising walls and trying to design things. If you do have metal flashings, which is on the left-hand side, and you would provide the appropriate sill pan flashing underneath it to direct water out, you may want to provide some additional height in order to allow either future roof replacement and or repairs if you need to, by having a counter flashing that's secured in place with some clips that can easily be removed so that you can do whatever repairs you need to, put everything back in without having to take off the wall panels, which could be very costly. Similarly, if you're doing a brick masonry project in which you need to replace through-wall flashings, if you plan ahead and you provide a counter flashing in that masonry wall system, that will allow a hem to your counter flashing to be secured onto the hem. You could take that off in the future if you need to replace your roof system. These are both work in progress photos. You never seem to get good photos at the end of the job, but these are decent examples as to how we could provide with a solution to address your future renovations with respect to wall conditions. Windows, louvers, and doors. Again, you want to make sure that you don't have your roof system tied up against any type of glazing. The mullions are designed to leak. If you don't have the water management directly below your window system, you're going to get water in your new roof system, and you're going to wonder where it's coming from. That is typically what we find. An example on the right is a before and after photo, some solutions that you can consider. This client had a significant amount of brick masonry through-wall flashing that would have needed to be installed because we needed to raise the roof system to meet the thermal requirements at the time. It also needed to have a significant amount of tapered insulation. So the window replacement was authorized, and in order to provide that counter flashing onto the roof system, we also incorporated new wall panels along the edge so that we could provide a watertight system, or water rain screen basically, with a moisture resistant barrier behind it in order to shed water out onto the roof system. Again, a work in progress photo, but it shows you some options that you can consider. Louvers, you usually run into a lot of louver issues on existing buildings. A lot of times these louvers have been abandoned. Mechanical equipment has been changed out. The louvers are just remaining in place. Nobody did anything with them, or they might have changed out some of the mechanical unit and only used a portion of that louver that we could install a blank op panel. So things that you might want to consider when looking at your roof is maybe getting a mechanical, electrical, plumbing engineer on board to take a look at your equipment to see if you could either A, get rid of these louvers, or B, potentially modify them, raise them, replace them, provide a new sill flashing underneath them in order to reduce the potential for water infiltration into your system. Again, rising walls. The photo on the left is the original building condition. The client was planning on demoing this building in the next 5 years, and they needed to replace the roof system. This stairway is basically a maintenance access way only. It doesn't require any accessibility requirements. So the options were remove the existing brick masonry directly above the door head in order to raise that door to provide you with a more robust opening, or modify the door itself. We replaced the door. We provided a new fire-rated door on it. You can see that the hardware is relatively at the same elevation height so that we can get access to from the interior to the exterior, but you can kind of see there's a significant change in elevation height with respect to where that louver is and the original roof system. So again, client just needed to buy 5 years. It was more economical to install new wall panels in lieu of going through and putting new through-wall flashings in, which is another option that could be considered. Rooftop equipment. In a perfect world, we would love to have a roof that you see on the upper right-hand corner. There's absolutely nothing on it. The least amount of penetrations you have, the better your roof system will be, because there's less chance of likelihood for one, trafficking on the roof, and two, penetrations that end up leaking. However, we know that you're likely going to have some rooftop equipment over your lifespan of the roof. These are just some examples. They can be very congested. They can be spread out. They can be too low to the roof system. They can have logistical issues where you can't really provide any space along the edge, which could be a fall hazard condition. These are all things that you want to take a look at. If there's any abandoned equipment that you can get rid of, we should try to look at that prior to doing any of your roof replacement. If there's a way that we can set it up so that you can still get drainage underneath it by providing some additional dunnage, that would be wonderful, because then you don't have to worry about any obstructions and you can get water off of the roof as quickly as possible. Things that are hazardous, we always want to take a look at this. We do a lot of work at hospitals. If there's any toxic vapor or hazardous materials coming out from an isolation room, there's a potential we want to replace this equipment as we're doing our roof renovations, because one, the equipment might be 20 years old and it might be time anyway, but two, we want to make it safe for both your operators that are up there as well as the roofing contractors that are doing work. So we might need to do new strobic vents. We might need to do new fan units or extend them up higher. We might need to extend the vent pipes in order to get them away from your interior intake. So those are things that should be looked at so that you can reduce any hazards on the building as much as possible. Communication equipment, we know that a lot of universities, high rises, commercial buildings are starting to put Verizon equipment, communication equipment up on their walls. They're allowed to lease these areas. They get a little money back in their pocket. So things that you want to keep in mind is if they're too low to the roof system and it's an existing roof system, they're all going to need to be raised. So one, you should consider, if you're planning on doing this on an existing roof system, making sure you have sufficient height in order to replace your roof in the future. Because in order to disconnect these units, you often need to coordinate with the supplier themselves, and you're not allowed to touch this. And this can usually result in not only cost implications, but schedule implications when you're trying to replace your roof system. So keep that in mind. It can significantly change how you do things when you're replacing your roof. Skylights, you likely might have a big warehouse or a cargo facility that wants to have that natural light in there. Skylights are considered fall openings, so you need to make sure that you have some form of fall protection, whether it be a cage on the inside, some form of rated glazing that can handle an impact, or a rail system around the perimeter of it, similar to the rails that are in the upper right-hand corner. Or if you're looking at it and you've got a skylight that nobody ever uses, it's been covered forever, there's interior ceiling tiles that prevent any natural light from coming in, you might want to just consider getting rid of them. And that's what is shown in the lower right-hand corner. It's the same photo as the one in the top, where the client had literally covered everything with drop ceilings because they didn't like the natural light anymore. We were able to get rid of a few penetrations in the roof system, which would significantly reduce the potential for water in their system. Smoke hatches. Smoke hatches were really big in the Massachusetts area from 1975 to 1991. They were required at all of the stairwells. They're not really required now. There are still some requirements in some jurisdictions, and especially in New York, where you would need to provide them, but there are other alternatives such as louvered vents and or windows that could be used as smoke release. But if you need to maintain the existing condition or the existing life safety requirements for your building without doing a code review to remove them, you may need to provide some structural modifications in order to provide a similar type of smoke release. The image on the left-hand corner was an old skylight that had a smoke vent on the top. The other two are options that you could consider, which would provide either natural light and or just an opening that you would release in order to get the smoke out. Things that you do also need to consider, though, these are considered fall hazards. And again, you would need to provide some form of fall protection, whether it be a grate on the inside or whether you put a rail around the perimeter of it so that if somebody was up on the roof, specifically firefighters, and these are open, they're not creating a fall hazard into the building. Elevator vents. Every elevator needs to have some form of ventilation to equalize the interior and exterior as it's going up and down. So if you've got enough flashing height, it's great if you don't have to modify that. You'd be able to tuck underneath it. But if you do need to modify the elevator vents in any way, shape, or form, you would be required to tie them into the fire alarm system. So that's something that we want to keep in mind, so that when you're looking at your existing system, is there a way that you can get around not having to raise those units? If you have to do it, you have to do it. But if you could reuse the existing, then you wouldn't trip the codes associated with the fire alarm. Ladders, stairs, and hatches. The photo on the left, you can obviously see that they had cut it at some point in time and it was too short, and they Mickey Moused it in order to get somebody to step up there. That's not considered safe. We would want to make sure that that gets removed and replaced. Specifically, when we're replacing a roof system, your maximum space from the top of roof surface up would be 12 inches, and you want to have your top rung at the level of the new roof surface as well, so that you're not creating a trip hazard. Similarly, in things that people always seem to get when they're replacing the roof and you're installing a new roof hatch, significant ventilation there, and that could result in significant increasing your hatch dimensions from where your existing ladder is. So you may need to remove and replace that interior ladder. And if you're doing that, you need to keep in mind that there are OSHA requirements with respect to clearances, bringing that ladder out 7 inches beyond the face of that interior wall. Make sure the rung is at the top level of your roof surface so that you've got that easy transition. And then you also need to have a fall arrest rail around it to protect yourself from this, as it is considered an opening and a fall hazard. Chimneys, whenever practical, we love to get rid of chimneys. I know that's not practical. We've only been able to do it on a handful of projects in which a client has literally bricked in a chimney on the inside for an old building, and we were able to get rid of them. They weren't used for chases or boilers or anything. But there's a good chance that you still are using your existing chimneys as boiler unit stacks. If possible, we would like to rebuild them, provide new through-wall flashing so that you're able to counter flash your new roof system into them. You might need to do some brick masonry repairs, address the capstone that's on there. Whenever practical, we would like to get some form of cap over them, one to reduce pest infiltration, but two, if you're not using it for a boiler system anymore, there's a good chance that any water that gets in there really doesn't evaporate because it's not seeing that heat. And if you've got a flue liner in there, it might not be allowing or resulting in any water that gets in there to dry out. So if you can get a cap on there, that would be a good thing in order to protect the interior of your building. Considerations for future renovations. Again, we talked about this. You might need to replace your roof system in the future. And if you've got a building that's going to be around for a long time, again in the future. So if you can pre-plan, if you need to raise your equipment now to replace your roof system, take into consideration that you might need to replace it again in the future. And we don't know what that insulation value may be. Raise your piping instead of the 8-inch minimum, which is suggested by the design industry. Maybe you go 12 inches, maybe you go 24 inches. If you're planning on doing structural dunnage in order to support your new equipment, make sure that you've got enough clearance on there so that your roofer doesn't need to crawl on his belly, because if he needs to crawl on his belly, it's going to cost you more money to replace that roof system. So if there's things that you can keep in mind in order to provide easy access to both your operations and future roofing operations, it could save you a significant amount of money. Other considerations is really, what is your roof system going to be used for? If you're on a hospital or you've got a executive who's going to be using this as a helicopter landing area, You know, what kind of penetrations might you need? What kind of fall protection might you have to have? What is your access going to be? Do you have a whole bunch of walkway pads that need to be incorporated into the system, which are either going to be for maintenance, or it's going to be just a general to go take a look at your roof area to see if you've got issues or concerns? Do you have to have lightning protection on your roof, from which you might need to ground every single penetration that's up there, or are you putting a mast system in that might allow all of the lightning to strike one location? These are all things you want to consider, because it's not just your roof that you're replacing, it's everything associated with it that's in contact that could be impacted. So let's get into the roofing real quick. It's Gail's opinion that you can't use one roof system for every building you have. It's just not practical. If you've got a lot of mechanical equipment, or if you've got no mechanical equipment, maybe you want to go with a cheaper membrane. Maybe you want to go with something more robust. Maybe you want to have puncture resistance your primary concern. Maybe you just need to put a temporary roof on there. Maybe you need to have something that's aesthetically pleasing or continuously walked on by others. So there are multiple different types of roof systems that could be considered for your particular building. Single ply membrane roofing, there's basically a thermoplastic membrane which incorporates PVC key or TPO. With the exception of the TPO, all of these products are thermally fused together with a glorified hair dryer to melt them and create a monolithic roof system. You can even get some accessories, such as the photo on the left, where you can heat weld some mimic seams on there in order to make it look like a standing seam roof system. TPOs are also thermally fused together with that hair dryer, but it can also be solvent welded in place depending on the manufacturer. Thermoset membranes are basically your EPDM, or are commonly referred to in the industry as rubber roofs. These are adhesive-based products. They come in wide rolls that get rolled out on the roof system, and then you use a seam tape or an adhesive to glue the two pieces together. Over time, they can break down, and you can often get some form of punctures in them. The photo in the far left-hand lower corner, this was a previous project where there was a significant amount of patches that were on there, mostly associated with falling ice from the structure above. You could get wrinkles, either as a result of the original installation, some air movement from the underside. You can have open seams. You can have punctures on curbs by people who might tie off on it. So there are a bunch of downfalls associated with single ply membranes, as well as pros. They're very good. We specified quite a few of them, but you want to take a look at what your roof system is and what your associated structures are in order to provide the appropriate membrane. Built-up roofing, historically, built-up roofing was all hot applied, in which you would have a kettle, a hot kettle, which would be about 500 degrees, and you'd basically mop out your asphalt into plies of membrane that became the waterproofing. There was a great track record with those. However, the hot applied systems were typically adhered down to the roof deck. So they were always heated up. You didn't have a lot of insulation with them, so they were almost self-sealing. No longer really something that is used anymore. And there are new technologies. Also, because we don't want to have a lot of gravel on there, many of the insurance suppliers will no longer allow gravel because they are considered a projectile issue. The newer technologies are multi-ply, cold applied sheets, in which you would have one or two base sheets, and then you would go down and put a granular surfaced cap sheet on top of it, similar to what an asphalt shingle might look like. That provides some redundancy with respect to your roof system, very puncture resistant, and it does provide a good aesthetic. Some of the issues, though, you could have mole runs, you could have some granular loss, you will have some blisters if there's any moisture that's trapped in that system. And again, though less probable, there might be some punctures associated with it if you have a significant fall issue on it, where dropping the equipment or hails. Spray applied, liquid applied roofing. This is becoming more common these days as a sustainable way to reuse some of your roof systems. They are typically applied in multiple coatings, which might be reinforced, especially over metal panel systems. They are currently being used on single ply systems as well, though there is a lot of preparation associated with it, and it's something that you might want to consider. But if you do that, you need to take into consideration that there might be some wet material underneath it that needs to come out in order to maintain your manufacturer's warranty. Spray applied spray polyurethane foam and liquid coatings, again, are an option. They're mostly used down in the southern states. They would have an elastomeric or coating that goes over that, which can fail relatively quickly, but it can be reapplied if need be. But things that you want to take into consideration is how are you flashing those items? Specifically the photo on the right, if you're going up against a metal wall panel, which is not considered watertight, and you're adhering right to it, well, you may now be allowing water infiltration into those areas, which can result in water getting back in your system. So you'd want to take that into consideration as well. Irma roof systems or inverted roof membrane assembly is basically putting a waterproofing layer directly on your deck. The purpose of this would be, one, to protect your roof system. Two, you might have some lower flashings that you just can't change, such as door thresholds that are critical in height, or some through-wall flashings that just could not be moved for a certain reason. By providing this system, you're keeping your waterproofing down at a lower level and increasing your overall insulation or flashing heights. Some of the issues, though, is that your paver and your insulation system is going to conceal your roof membrane. You really won't be able to identify if you have a leak or a concern. Also, it's a significant amount of weight that can be applied to your roof system, so you need to make sure that you've got a structural evaluation performed to make sure it can handle the weight. Other things that you might want to consider is providing some form of leak detection system, such as an electro field vector mapping, so that if there is a leak and it gets into the system, you'd be able to find it. Vegetating roof is also another type of Irma roof system where, again, you're putting that waterproofing down at the lower level. You could have intensive media such as trees, large gardens, areas with a significant amount of weight on it. Again, you might need to do a significant structural evaluation on that, or you would have an extensive roof system where you might have 4-inch wide deep trays that you've got some sedum or local vegetation that's growing in there, maybe some rocks around the perimeter of it. Again, rocks really aren't something that most insurance suppliers will allow anymore, but it's something that you could consider. If properly designed and you've got the appropriate wind rating or uplift requirements there, that it won't create a major issue. But things that you need to take into consideration is, again, your structural review. What kind of maintenance might you need to do on it? You might still need to cut the lawn. You will need to provide some form of irrigation. Do you have the appropriate load to handle the water capacity and snow capacity that will be on there? Because if you don't, you've got a good chance to have that image that showed up in the beginning of the slide where you have a structural collapse, which can damage the entire building. Steep slope roofing, there's multiple different kinds. You've got metal roofs, which can be flat lock standing seam or batten seam system. You got shingles, slate, asphalt, synthetic, wood shakes, terracotta tile roofing, Bermuda slate. Basically, metal roofing, it looks really good. It does provide a 40-year plus lifespan. Some of the coatings, if you've got an aluminum coating on it, though, typically only have a 20-year warranty. But these can provide a good service life for steep slope roofing so that you can reduce the potential for water infiltration in, and it's basically a continuous system. However, you can have some galvanic reaction, some rust through, some delamination, some oil canning. You'll have thermal issues in which you may have to have some form of expansion joint in there if the clips aren't secured correctly. And you could have the potential for capillary action if your seams are not sealed or properly sloped in order to shed that water out quickly. Shingle roofing, there's asphalt shingle roofing, multiple different styles. You could have 3-tab architectural shingle, product that actually has a shadow line that looks similar to slate. On the right-hand photo, you've got a slate shingle roof system, which you could use a synthetic product as well. These are more for historic buildings, but you could use them on anything. However, you do need to check your structural capacity of it to make sure that you're not overstressing the roof system. Some issues or concerns, asphalt shingles, you could have a significant amount of granular loss. This might be associated with either some shingle bake or people trafficking it on a regular basis or high wind scour. You could also have some ice dam concerns if you don't have the appropriate ventilation underneath it, where in the winter climates where you would get water and snow capillary action that would get in there. Since these are a kinetic roof system, you need to make sure that the water gets off as quickly as possible. With respect to slate, again, you could have cracks, displacement, loose units. The contractor may not be knowledgeable in the slate because it's really a lost art, and they may be overdriving the fasteners or underdriving the fasteners, which could be damaging your slate shingle either above and below, which could result in shedding, which is a natural phenomenon. When the slate breaks, comes down, there might be a ribbon in the slate that results in it breaking. So these are things that you want to take into consideration. Terracotta on tile roofing, there's multiple different kinds. You've got a concave up, concave down configuration. They're intended to shed off roof. Terracotta is used in the New England climate, but it's more prevalent down in the lower southern states. Again, there is a concern with cracking, displacement. Making sure that you have the appropriate weather barrier underneath it is very important so that you can shed water out should any damages occur. So key takeaways, you should really be making sure you understand the building code requirements, your industry requirements, what's associated with your roof replacement that you need to take into consideration before you even consider replacing your roof. Once you know what you want to do with your roof, please take a look at what your rooftop equipment might be. Can you raise it? If there are things that you can get rid of, what might you need to repair? Do you need to address any of your masonry through wall flashings? Do you need to redo maybe some of your panels or doors? Those are things that you want to consider as part of your roof replacement in order to get a successful project. And then what would you consider for future modifications? If you're already raising equipment now, might you want to consider raising it a little bit higher? Do you need to provide some modified configuration of dunnage so that you can get underneath there in the future? What kind of railings might you need in order to protect your people from fall hazards? So with that, I want to thank you all. And if there are any questions, please feel free to let me know.
Okay, yes, Chris, we have some questions for you today.
Okay.
The first question is, what roof membrane would you recommend for these projects?
Well, again, we don't recommend just one roof system. It really has a lot to do with what's going on with your roof. If you don't have a lot of access on it, you might want to consider a single ply system. If you have a lot of access on it and they need to maintain equipment on a regular basis, you might want to have something that would be more durable and slip resistant. So maybe you go with an SBS modified bitumen system.
Okay, thank you. Our next question is there a code requirement to use an engineer for a re-roof design instead of directly hiring a contractor?
So that, I think, really depends on your jurisdiction. In the state of Massachusetts, most building officials will require that you have a construction control affidavit, which is by a design professional, especially if you're doing any structural modifications. It's required that a structural engineer were to review it. So just having a roofing contractor go out there and replace your roof, I mean, if it's just a shingle roof, it might be just fine. But if they have to apply for a permit, you need a structural engineer or a registered architect to sign off on this, you would need to go to the professional.
Okay, thank you. Our next question is, are drone surveys alone sufficient for evaluating existing conditions on steep slope roofs? Many steep slopes are challenging to access for traditional inspections.
So if you are just trying to do a visual understanding as to what the condition of the roof is, most times a drone survey would provide you with enough information to get an understanding as to what's going on. However, you most likely will still need to do some form of destructive test cut with respect to figuring out what your conditions are, what your roof deck might be, what you might have for hazardous materials. So you would probably still need to do some form of access lift in order to get up there to remove a portion of it. But for the most part, drone would provide you with a decent understanding of what the substrate or conditions are above.
Okay, thank you. Our next question is, have you ever used synthetic slate or tile roofing? If so, in what situations would you consider using synthetic materials?
So I have used synthetic slate in the past. One, it was for cost. Two, it was for the existing loads on a structure would not meet the current requirements without doing a significant amount of structural modification. And the weight limits associated with the synthetic slate are much less than that of natural slate. So we were able to match the aesthetics, but still provide a system that would not require a significant amount of structural modification.
Okay, thank you. Our next question is, if vent piping needs upgrading, what's the best way to go about bringing those up to code?
It really depends on what your issues are. If you've got that 1-inch vent pipe that we talked about, if you can get access from the inside, cut it on the inside, you need to be 12 inches down below the roof deck and extend it up that way, great. If you have a vent pipe that has the appropriate height, the appropriate interior dimension, and you already have enough for your flashing, we have put new hub connectors on so that you can just extend it higher above the roof system that way. But it really depends on what your conditions are.
Okay, well, thank you. Our next question is, are there alternative solutions to address ponding issues on a new roof surface? Most warranties won't cover ponding issues. Ponding accelerates the breakdown of the SBS roof.
So yes, there are other options that could be considered. Some of them can be costly. Again, it depends on what your conditions are. We have in the past installed augmenting drains in some locations. Sometimes that's cost prohibitive. We have also coated some of the SBS products, which would provide a monolithic coat over the whole thing. But again, it really depends on what the extent of your modified bitumen is. Maybe if you were to provide some additional crickets or some additional plies over those areas to build it up, sometimes that just pushes water someplace else. Again, it would have to be a case-by-case basis so that you can take a look at it.
Okay, thank you. Our next question is, when conducting building conditions assessment, visual inspection of roofing systems, how do you go about it and what do you look for?
So a visual observation would basically be walking on the roof or getting a lift in order to look at it, or a drone, and go around and take a look at what kind of punctures you may have, if there are blisters, if there are open seams that could allow water infiltration in. As part of that visual observation, we would also look at the rising walls, door thresholds, etc., anything that could be contributing to water infiltration into the building, so that we can understand what the next steps might be, which would, after we discuss with you what kind of issues there are, Maybe we do some destructive test cuts. Maybe we do a thermal analysis to see if you've got wet insulation. Maybe it might just be a simple repair that needs to be done. But the visual observation would look for what kind of issues or concerns we can see right up front.
Okay, thank you. I have the next question is, I don't think it's complete enough, but the person is asking, do you have a suggestion for replacing a slate roof?
Yes. There are multiple options. You could replace the roof with a slate roof. You could go back with a synthetic slate roof. We've had clients who didn't want to go back with slate roofing and wanted to go the economic way by using asphalt shingles. You could use a standing seam roof system, whether it be aluminum, copper, etc. Something though that you should keep in mind is if you have a slate roof, there's a good chance that it might be a very old building, so you might have to deal with the local historic commission. So you might want to look into that prior to just replacing a slate roof, because they may ask you to go back with that slate roof.
Okay, thank you. Well, that's all the questions we have at the moment. So Chris, I want to say thank you so much for taking time out of your busy schedule to do this webinar today. You're getting great feedback on the information that you're providing. So
Great.
Thank you so much.
Thank you.
And as always, we are getting another question about presentations. So as I tell everybody, as soon as I get a copy of the presentations, I will send it out to those who request it. If you are an EDU, we're only sending these to our EDU partners. But anyway, just want to say thank you again for doing this great webinar, and to Gail for giving you the time to do this. And to our attendees, as always, thank you for taking time out of your busy schedule to be with us. So until next time, we only have a couple more webinars until our webinar season is done. So until next time, be safe, stay healthy, and let's be kind to one another. Thank you so much, and see you next week. Bye-bye.
Thank you.